Periodically, the Hillsborough County Water Department tests the drinking water of homeowners for contaminants such as lead. The lead level in water specimens collected for a sample of 10 residents of the Crystal Lakes Manor subdivision are shown in the table below. So we're given 10 data points measuring the lead level in the water, and the units are in micrograms per liter. Construct a 99% confidence interval for the mean lead level in water from Crystal Lake Manors and interpret the interval. So to get a confidence interval with this particular data set, I notice that they don't give us a population standard deviation. So we're going to have to estimate that with the sample standard deviation. I also need the sample average. And because I'm using the sample standard deviation and the sample size is pretty small, I'm going to use a t distribution to construct my confidence interval. So I'm going to be looking at the formula x bar plus or minus t alpha over 2 and then s divided by the square root of n. Now, putting these 10 values in my calculator or Excel, I get that the sample average is 2.8856, and the sample standard deviation is 3.92. And then I think I have all the values I need except for the t value, and my confidence level being 99%, alpha is going to be 0.01, and then alpha over 2 would be t sub 0.005. The degrees of freedom will be the sample size subtract 1, so in this case I'll have 9. In the t-table, if I look under the column 0.005 and down to row 9 for the degrees of freedom, I get my t value to be 3.250. And then I think I have everything I need to plug into the interval. I've got 2.8856 as the sample average, 3.25 as my t alpha over 2 value, 3.92 was my sample standard deviation, and then sample size 10. Okay, and if I calculate what's called the margin of error, I will get that being plus or minus 4.03. And my confidence interval then is a negative 1.15, where I take 2.8856 and subtract 4.03 up to 6.92 when I add 4.03. To interpret that confidence interval, I'm going to say there is a 99% probability that the true population mean lead level is under 6.92 micrograms per liter. Notice that I interpreted the confidence interval as just under the 6.92 micrograms per liter. It doesn't really make sense in the context of this problem to think of negative lead amounts. So I just basically started the confidence interval at 0 up to 6.92. Now the next part of this is to try to come up with a sample size that we can reduce our margin of error to being 0.5 micrograms per liter. Now, what is our margin of error at this point? That's the 4.03. So what that would say is that my 2.8856 average is an estimate of the population average. That population average then would be within 4.03 micrograms per liter of that value. I want to get an estimate so that I'm within 0.5 micrograms per liter of the average. So what I'm going to do is use my sample size formula, and that formula is n equals z alpha over 2 squared sigma squared over my desired margin of error squared. And for my values here, I'm going to put in the z-score at a 99% confidence level. That would be a 2.5. Actually, you can interpolate the value coming out of the standard normal table to be 2.575, which is right between the 2.57 and 2.58. So I went ahead and went with the 2.575. But if you did the 2.58, that would be fine. And I want to square that. And I do have an estimate of my standard deviation from my sample. At this point, according to the language of the book, we could consider that a pilot study. And then my margin of error that I want is 0.5. So I'm going to divide by the 0.5 squared. When I do the calculations on that, I get 408. So if I go into this neighborhood and collect another sample, and this time not of 10 but of 408, calculate the average on that sample, then that average, that sample average, will be within 0.5 micrograms per liter of the real population average. So I will have reduced my margin of error quite a bit, from 4.03 to 0.5. But it's going to take a lot larger sample than 10 to do it. I'll have to get a sample of 408.